Hello, my name is Gargi Ghosh. I'm a PhD student in Public Health of University of West London. Thank you for inviting me today to present part of my research study, that is impacts of obesity on health and well-being of older adults in England. First of all, it is important to briefly discuss about the study background. According to Public Health England, England is one of the most obese countries in the world, with 1 in 4 adults being obese. Although obesity is a worldwide problem and it is one of the biggest public health challenges today, with increasing prevalence and incidence in both developed and developing countries. Moreover, the increasing life expectancy and obesity jointly lead us towards disability and dependencies. However, the largest negative effect of obesity is not only on the individual's life expectancy but also on the number of years an individual can be freed from disability. Therefore, the health status of obese individual is usually unsatisfactory and inferior to that of individuals with normal weight, and the life expectancy of obese individual is on average shorter by 2 years. However, as yet little is known about the impact of obesity in older adults on current health status and its effect on health and physical and mental well-being in particular. Now, the literature gap that has been identified from the background study is that the Obesity Care Pathway Toolkit by National Obesity Forum, NHS document, that is Care Pathway for the Management of Overweight and Obesity, NICE Guidelines on Obesity, the report of the working group into joined up clinical pathways for obesity by representations from various health regulatory bodies, and Wandsworth Healthy Weight Care Pathway Toolkit by Public Health Wandsworth Council did not mention the course of care for older adults with obesity for all aspects of their well-being and quality of life related to their current health status. Therefore, the aim of the study is to predict the connections between overweight or obesity and their effect on various dimensions of health and well-being among older adults 50 plus years old in England. So, the research question is there any link between current health status and overall well-being of obese older adults in England? Now, to briefly discuss about methodology and data analysis, the impact of obesity on health and well-being have been planned and measured by a nationally representative large-scale survey dataset from the English Longitudinal Study on Aging, or ELSA. This demands quantitative research method because it provides data that are precise and arguably unambiguous. The ELSA dataset is freely available to all the researchers through the UK Data Service. The data were already collected and stored to be analyzed, and all the ELSA waves have been approved by the National Research and Ethics Committee, that is London Multi-Centre Research Ethics Committee. For my study, a cross-sectional analysis of the ELSA wave hit cohort dataset data has been undertaken. Now, before coming to data analysis, I should just quickly mention the hypothesis of the study. The three null hypotheses of the study are: firstly, there is no statistically significant link between obesity and subjective health status of older adults in England. Secondly, there is no connection between obesity and objective health status of older adults in England. And finally, there is no relation between current health status and overall well-being of obese older adults in England. To test the research question, exploratory data analysis with percentages from chi-square statistics and also multivariate logistic regression analysis, that is binary and multinomial, as well as multiple linear regression analysis, have been applied with the help of SPSS software package version 25. Here my outcome variables are: number 1, health status by subjective and objective health status, and number 2, well-being by control autonomy self-realization and pleasure scale, or CASP 19. The predictors are degree of BMI, age, gender, marital status, smoking, alcohol, education and employment. where BMI is calculated by individual's weight in kilogram divided by individual's height in meter squared. And according to the degree of BMI, obesity is classified as normal weight, where BMI is greater than equal to 18.5 and less than 25. Overweight, where BMI is greater than equal to 25 and less than 30, and obese, where BMI is greater than equal to 30. Respondents' age is categorized into four groups as 50 to 60, 61 to 70, 71 to 80, and 81 plus. Gender is classified as male and female, marital status as single and married, where single represents widowed, divorced, or currently not in any relationship, and married represents currently with existing partner. Smoking represents if the individual is current smoker, and for alcohol if the individual drinks rarely or frequently. Level of education is measured by age completed formal school education, and it is grouped in three categories as no education or less than equal to 14 years old. Secondly, living education in between 15 to 18 years age, and finally living education at 19 years age or over or still continuing. Participants' employment status is grouped as unemployed or retired, and employed or self-employed. The self-reported health status or subjective health status is labeled as in five categories, that is excellent, very good, good, fair, and poor. And objective health status or medically diagnosed 11 morbidities are grouped as no morbidity, single morbidity, comorbidities, and multimorbidity. Lastly, well-being is measured by 19 items of control, autonomy, self-realization, and pleasure scale, that is CAPS 19, and all the responses have been summed up to have a total score ranging from 0 to 57, with higher scores reflects poor well-being. Here, to make a conclusion about the hypothesis with 95% confidence, the p-value of the chi-square statistics should be less than 0.05, that is p less than 0.05. Now the results from the exploratory data analysis have been visually exhibited. Firstly, on histogram to display counts of data for the purpose of determining subjective health status, and secondly, in a combination of bar diagrams and linear graph to determine objective health status or clinically diagnosed morbidities. For the histogram, the number of respondents within a population are plotted on x-axis according to the frequency distribution for each independent variable. The outcome variable or the degree of obesity by BMI classification is plotted on y-axis as normal, overweight, and obese. The graph shows that excellent health status has been documented by mostly normal weight respondents, and fair or poor health status has been documented by mostly obese participants. Now, to show the prevalence of morbidity by increasing BMI and age, x-axis is representing the four groups of morbidity, that is no morbidity, single morbidity, comorbidity, and multimorbidity. And y-axis is representing the percentages of normal, overweight, and obese population suffering with any type of morbidity. There are four graphs according to the age groups to represent the association between BMI and morbidity among the four age groups, that is 50 to 60 years, 61 to 70 years, 71 to 80 years, and 81 years plus of older adults in a combination of bar diagrams and linear graph. The graphs show that obese respondents hold the highest percentages of comorbidity and multimorbidity for the 50 to 60 years, 61 to 70 years, and 71 to 80 years age groups. However, for the 81 plus age group, multimorbidity is mostly prevalent among the overweight population, although the comorbidity is mostly prevalent among the obese population. Simultaneously, as the age is increasing, the prevalence of comorbidity and multimorbidity are rising, whereas the number of reported single medically diagnosed morbidity is reducing. Now the binary logistic regression model has been applied to analyze subjective health status, where the dependent variable, that is self-rated health status, is grouped as excellent and poor, that is dichotomous or binary in nature. and multinomial logistic regression have been predicted to be the best suited to analyze objective health status, as the dependent variable morbidity is polycotomous in nature. Lastly, the multiple linear regression is assumed to be well fitted to analyze the association between obesity and well-being, where the dependent variable is well-being by CASP-19. Here, the brief results of binary multinomial logistic regression and multiple linear regression have been documented. Firstly, obesity by BMI measurement is statistically significant, that is p less than 0.05 with subjective and objective health status even after adjusting the other predictors. Secondly, the unadjusted model shows that obese is the better contributing predictor to explain poor well-being than overweight, where normal BMI is the reference group. However, the adjusted model 2 shows that for every 1 kilogram per meter square increase of BMI, resulting in increasing poor well-being by 0.003 for overweight participant and by 0.364 for obese participant than the participant with normal BMI when all other predictors are held constant. Moreover, the participants who are obese and 81 years plus age are more likely to have poor or fair subjective health status than normal weight 50 to 60 years old participants. Furthermore, every 1 kilogram per meter square increase in overweight and obese, we expect a progressive decrease in subjective health status comparing with the normal BMI. In addition, obese 61 to 70 years old, unmarried, and a current smoker, employed, and age leaving formal education at 19 years or over are the predictors that have been found statistically significantly predicting subjective health status. Interestingly, for every 1 year increase of age resulted a sense of better well-being than the 50 to 60 years old respondents. Consequently, 81 years age group is the worst contributing predictor to explain poor well-being than 61 to 70 years and 71 to 80 years age group compared to the 50 to 60 years age group participant as a reference group. The participants who are obese, male, current smoker, and currently employed predictors have been found statistically significant to predict comorbidity in relation to no morbidity. Also, obese 61 to 70 years age group, 71 to 80 years age group, and 81 plus years age group male, current smoker, and currently employed predictors have been found statistically significantly predicting multimorbidity in relation to no morbidity. And finally, for obese respondents, the odds of having morbidity are 3 times, having comorbidity are 4 times, and having multimorbidity are 4 times as large as the odds for an overweight individual. The analysis of variance or ANOVA table of multiple linear regression indicates that the regression model predict the dependent variable significantly well. Here p less than 0.0005, which is less than 0.05, and indicates that overall the regression model statistically significantly predict the outcome variable, that is poor well-being by CASP-19. So it is a good fit for the data. Now the study aims to contribute to the field by providing an update to the obesity care pathway toolkit developed by the National Obesity Forum, by providing research outputs to inform others in the field who are also designing services for older people and contributing to this body of knowledge, and finally by contributing to social care policy. Thank you so much. The list of the key references are here if you want to see. And thank you. If you have got any question, I would like to answer. Thank you for listening.